Okay, sixth grade. We're gonna working through session one, and we're continuing to work through these problems. And I'm gonna be going through and hopefully just having some fun, just really being kind of creative, also, not just reading through and finding an answer really fast, but there's a lot of cool math in here. Something I thought of is if you have a question, I'm gonna put my email here, and then I'll erase it so you can just write this down. But if you have any questions, or if your parents do, it's C. Freiberger at dundeecs.org. So any questions, or if you have something, that's C. Freiberger at, that's an at sign. Looks kind of like a blob right now, but it's an at sign. Best I could do. dundeecs.org. So, email anything if you want to see a particular problem worked, or if you need to get a hold of me with a question, just let me know. And I'm trying to get these little videos out, but something always seems to go wrong when I'm doing this, and I have to restart or something. This is my second go around on this one, so it's taken me a while to get good at this. All right, let's have some fun. Okay, first of all, math is fun. Math is it's an opportunity to be creative. Math is what is solving all of our problems right now with coronavirus. We have they're using math to figure out how many hospital beds, how many respirators we need. They're using math to figure out how to ship those things to the right places. They're using math to figure out, well, how do we how many people can we test at one time? It is all math that these guys are using, and it's a lot of it is math just at the sixth grade, okay? Because you guys know percents and all that kind of cool stuff. They're trying to figure out how to run our economy. It's all math. It's all math. Okay, so let's take a look at this. Which expression is equivalent to the phrase below? So an expression, just to remember, expression, true or false, has an equal sign. No equal sign. Okay, there's no equal sign. That is, what's it called when it has an equal sign? 1, 2, 3. Hopefully you said equation. An equation has an equal sign. So an expression, we just evaluate an expression. We just figure that out. We don't solve it, okay? Like with an equal sign. So here we go. So you basically have to learn how to read the words, and then you're putting it into the math code. That's all this is. Okay, math it's really like a form of a written language. It just puts using symbols and numbers. It is saying all of these words right here. You can see why it's like, instead of saying all those words, let's just put these in some symbols. So that's what they did. Okay, so this says the quotient. So right away, you got to know what's the quotient. Okay, you got to know these four terms: quotient, product, sum, difference. They come up over and over and over again. And a lot of times, boys and girls will miss problems just because they don't know those things. So here we go. And your choices are addition, subtraction, multiplication, division. All right, we're going to do a quiz. All right, difference. On the count of three, which is it? Addition, subtraction, multiplication, or division? 1, 2, 3. Subtraction. Hope you got it. That one's out of there. Next one is sum. What's the sum? Addition, multiplication, division. 1, 2, 3. Addition. You got it. Product. Ooh, we're down to 2. Is it multiplication or division? 1, 2, 3. Multiplication. Good job. And the quotient is division. Division can be shown in 3 ways. So let's make sure you understand that. Let's say I have 10 divided by 4. We can have 10 divided by 4, and I can show it with a fraction. So a fraction form also is a way of showing division. 10 divided by 4. This is 4 parts to make a whole. I have 10 parts. Oh, let me pause that. Okay, back with you. That's why it's hard to get these out. That was the phone ringing there. So we were talking about just different ways to show division. So 10 fourths means there's 4 parts to make a whole. I have 10 parts. So how many wholes can I make? Well, how many groups of 4 are in there? There are 2 groups, 2 whole groups, 10 divided by 4, 2 whole groups, 2 parts left over out of 4. Or 10 divided by 4, 2 and 2 fourths. Okay, so let's take a look at our problem here. There are lots of ways to do this. You can be really creative. We're going to draw it and use a number line first. Oh, no, sorry. I'm getting ahead of myself. So we're going to go through and look and see what this information has. So we know it's going to be division. So I want you to take parentheses, the quotient of something, the sum of 2t and 2. So whenever you have a quotient, you're going to have something divided by something. So we got 2 things we're going to be dividing. So here's the first one, this first part, and twice the cube of s. So here's our 2 parts. We're going to take this part divided by this part because it says quotient of. So see if you see that. Does that make sense? You got two big parts there. Okay, now all we got to do is just crack the code. Just crack the code. Here we go. So we've got the sum of 2t and 2. Well, we know what sum means. It means to add. So we're going to say 2t plus 2. That's all we have here. Okay, that's what our first part is. So we want the quotient of that, and then this part over here, twice the cube of s. So twice, that means 2 times. Cube of s just means instead of the square of s, you have the cube of s. So if you have s squared, s squared, that's s to the power of 2. That's all that means. S cubed just means s to the power of 3. So twice the cube of s, so 2 times s to the power of 3. Okay? So we have these two things. We're going to divide them. Typically, you're going to show in a problem like this division with a fraction line. So we're going to show our division. So we have the quotient of the sum of 2t and 2, and we're going to have the quotient of that and this, 2 times s to the power of 3. So you come down here and you take a look, and of course it doesn't look anything like that, nothing like that. Oh, you got two of these, and this one has 3 times s squared in the bottom. Now this one, so this is our answer. There's a difference here. It has 2s to the power of 3. So you can also write this, because the whole idea is to make this code as easily, and we don't want to waste any time. So what mathematicians realize is I don't need a multiplication sign. If I put that number right next to that letter, so that is an s. If I put it right next to that s, that means 2 times s. Okay, so there, just save some time there. All right, let's go check out the next one here. Okay, this is the one I was talking about, that where we were going to do a drawing and a number line. So this is a really cool problem. There's probably like 5 different ways to do it. Okay, so let's just take a look at it and find out, let's get a picture of what's going on here. Always want to draw a picture of your math, and then that'll tell you what kind of math operations you can use. Or if you even need to use math operations at all, you can just maybe draw and think it through. Just thinking it through. That's math. All right, here we go. Custodian plans to repaint some classroom bookcases. She has 5 1/4 gallons of paint. Okay, so we can imagine now. Let's just say it's a big old paint thing, and it's got 5 1/4 gallons of paint in here. 5 1/4 gallons. All of the bookcases she's going to paint bookcases are the same size. They each require 3/4 gallons of paint. Okay, so she's going to paint one. She's going to use 3/4 of a gallon of paint. So we can imagine that. You go in that paint bucket, dip it out, and paint a bookcase. And our question is just, so how many bookcases can she paint? How many bookcases can she do? So let's just draw a picture of it. So first, let's just say she goes in, she takes out 3/4 of a gallon, she does a bookcase, and there's 3/4 of a gallon to do the bookcase. Then she does the same thing, and she does another one, okay? And she's taking out 3/4. So she's taking out, notice, so that tells us right there what's going on. She's subtracting 3/4 each time. She's subtracting 3/4. So we're going to just, if you're subtracting over and over and over again, think about what kind of a problem that is. We don't normally think about subtracting over and over and over again, but a lot of times we think about repeated addition, like 2 plus 2 plus 2. Well, we can write that much quicker as 3 times 2. So repeated addition is multiplication. So guess what repeated subtraction is? You guessed it, it's division. And if you think about long division, that's all you're doing. You're just subtracting over and over again. So let's just draw a picture. Let's solve this with a picture first. We know it's division. Okay, so I'm going to redraw some of these here. Clear some space out. They don't give you a whole lot of space here. So here's what we have. I'm going to redraw my main bucket. I've got 5 1/4 gallons. Okay, 5 1/4 gallons. So let's just imagine, each time we're taking out 3/4 of a gallon, 3/4 of a gallon, and then we're going to paint a bookcase. So we could actually draw all of this paint out like this. We could actually draw the 5. Let's do it this way. Let's just draw the 5 1/4 gallons separately. You know how paint comes. So here's 1 gallon, 2 gallons, 3 gallons, 4 gallons, 5 gallons. But we actually have a 1/4, so we have a little bit more. So I'm going to split all of my gallons into 4 parts. Okay, split them all into 4 parts. So can you imagine this now? Here we go. Here's a gallon, and it's full. Here's a gallon, and it's full. A gallon, 3 gallons, 4 gallons, 5 gallons. Now I have 5 and 1/4 gallons. So see if that makes sense first of all. So I've drawn each one of these gallons. I'm pretending like I can separate them into 4 parts here. I have 1, 2, 3, 4, 5, and 1/4, and that comes from this up here, 5 and 1/4. Okay, so far that's all we're doing. Now we want to use 3/4 to do to make a bookcase. So we could just go in here and say, okay, well, I'll just circle 3/4. There's one bookcase. I could just go here and just circle this. Literally, I could say, well, let's do another one. I'll circle this. There's another 3/4. Now that's getting kind of messy, so I could just say, you know what? I'll just put numbers in here. There's 1, 1, 1. All of these are used to make one bookcase. I have on my second bookcase, I can just put 2, 2, 2. This is just one way to do it. However you want to figure out how to account for the 3/4, you can be really creative with this. But that's what these numbers are standing for. So this is used for my second bookcase. So now I'm going to use the next 3 for my third bookcase, the next 3 for my fourth bookcase, the next 3 for my fifth bookcase. Okay, my sixth bookcase I use a quarter, I'm using 3/4, and my seventh bookcase. So I haven't done anything, nothing fancy here. All I've done is just draw a picture, and that's math, and I've got my answer. You can be super creative with this, okay? Let's say you like using number lines, and maybe just you want to solve it with a number line. There's another way to do it. Let's take a look at that way real fast here. This would be super fun. You just make a number line, and you can count your bookcases down here. So I'm just going to say there's one bookcase, and I use 3/4. I do another bookcase. That's 3 more quarters. Now that's 6/4. Again, what I just did is I just said 3/4 plus, all I'm doing is adding 3/4. 6/4. Okay. So how much paint? This is my paint down here. Okay. And these are my bookcases. I could actually turn this into a ratio problem with the double number line, but we're going to run out of time. But you can see there's just a lot of super cool ways to do this. So you could even think of a double number line here. But there's 6/4. So how much would that be? Well, that would be 1 2/4. So far, I've used up 1 2/4. I've got 5 1/4. I can keep on going. Let's do another one. Now you can see what's happening here. I'm just 3/4 each time. 3/4 each time. How much paint is that? Well, 9 divided by 4, that's 2 1/4 gallons so far. Let's do another one. 12/4. It's 3. I know what I'll do. I'll challenge you guys to come up with a different way of doing this, and then you can email me. I'll put my email on here, and you guys can email me and tell me about how you solved it. That would be really cool. Okay, here's another one. This is 15/4. Okay, so that's 3 3/4. So I still got paint left. Here. Here is three more quarters, and you can see it's just going by threes. 3/4, 3, 4 stays the same. Okay, all right. So that gives me four parts. 4 parts to make a hole. I got 18 parts, so that's 4 holes. Okay, and 2/4, and one more, and that's 21/4. Okay, is that right? 18 and 2 and 1 is 20. Yep. And so I got 21 parts divided by 4, so that's 5 1/4, and that's all the paint that I have. How many bookcases? We got 1, 2, 3, 4, 5, 6, 7. And you know what? Back here, I could have even stopped and said, wow, I'm already at 3 gallons. You could have thought it through and just said, I'm at 3 gallons, so it's not here, it's not here. If I double that, I've done 4 for 3 gallons. There's a ratio for you. If I double that, 4 for 3 gallons, that'd be 8 for 6 gallons. So clearly I can't get up here. So I could have stopped right there and I could have had the problem. All right, there's a bunch of other ways. So maybe instead of me taking up time, because I'm trying to talk too quickly through here, let me put my email on here, okay? And if you come up with a fun way to do this, or just anything, something different, don't go out in the garage and grab 5 1/4 gallons and start pouring 3/4 on the floor or anything like that. That's not going to be popular. But there's a lot of ways to solve it. So here's my email: cfryberger@dundeecs.org. And I can't have you make the comments on the YouTube. I tried to figure out how to do that, but because this is made for kids, I don't think you're allowed to comment back. But maybe I'll talk to Mr. Bailey and we'll figure something out. Okay, let's take a look at the next one here. Okay, so let's... Okay, oh, let me pause this. Okay, I think this is recording, but something's wrong with the webcam, so I'm not going to worry about it. Not sure if it's capturing me at all, but let's go through and take a look at this one. All right, it says Carly purchased 9 1/2 pints of ice cream for a party. So she's got a bunch of ice cream, and then each guest is going to be served exactly 5 or 3/5 pint of ice cream. So basically, which is the greatest number of guests? So she's got all this ice cream again, just like the paint problem. Okay, here she's got 9 1/2 pints. Okay, 9 1/2 pints. And each guest gets 3/5 of a pint. So 3/5. This is a guest. So we can imagine this going on. You're scooping this out. So each time she's taking out 3/5. So again, each time we're subtracting 3/5, 3/5. So this is a division problem, okay? So we can set up these two fractions and divide them, or we can think through, maybe you want to think through how to draw this. So there's a lot of different options that you can do. Let's see, on this one, let's do something different. Let me get rid of this here. Let's look at another creative way to do it. Let's say, so we want to know how many guests. Each guest gets 3/5. So what if we say, here's one guest, 3/5. And we have how much ice cream altogether? We have 9 1/2. That's our total ice cream, 9 1/2 pints. So what if we say, here's 5 guests, because that's what these are. The question is how many guests? So here they are, there's our guests. So if we say 3/5 times 5, okay, so if there's 5 guests, so 5 copies of 3/5 equals, and again, you can either think of it as, I could put it over here on this side, 5 copies of 3/5. Maybe that's the easier way to think about it. That's 5 times 3/5. That's 15/5. Okay? So what we just found was we're trying to figure out how much ice cream have we used. 5 guests, they each got 3/5. We use 15/5, which means we just used 3 pints. So we have how much? We have 9 1/2 pints. 9 1/2 pints. So we might say, you know what? You could actually look at this. Listen to this. So 3 pints serves 5. You could actually turn this into a ratio problem. Okay? Well, if 3/5 serves 5, if 3 pints serves 5, then you could say, 6 pints serves, 6 pints would serve, if we double the number of pints, we double the number of people, 10. And then 3 more pints would be 9 pints. That would give us 5 more people. So 9 pints, oops, I lost something there. 9 pints serves 15. Ooh, so we automatically know it's not this and it's not this. But we have a half of a pint. We have 1/2 of a pint. So do we have enough to serve 1 more guest? So let's take a look at that. We have a half, right? If you followed that, let's go back. I found out that 3/5 for 1, for times 5, for 5 people, I would use a total of 15/5. I would use 3 pints. So let's do 3 more pints. Means 5 more people. There's where I got the 10. 3 more pints gives me the 9 pints. 5 more people, that's 15. But I remember I have 9 1/2. I have a half a pint. Is that enough? I need 3/5. So the question is is 1/2. Is that equal to or greater than 3/5? And if you look at these two fractions, using what you know about fractions, I want you to think, is 1/2 enough? Can I make 3/5 out of that? How would you compare that? How would you compare it? Really, really interesting. So I could just draw that. I could do, here's 1/2. And I got to just be careful that I make these the same size. And it's hard to draw fifths. I'm going to need 3 lines. So 1, 2, 3, 4. So if I draw it, I can say here's 1/2, and there's 3/5. So I just barely, I just don't have enough. If I had a little more ice cream, I could do 16. So there you go, right there, by using your knowledge of ratios and fractions. That's pretty cool. You know, that's what I'm telling you. These are really fun. Okay, now, so it looks like my answer is 15. Let's look at a different way real fast. Let's take this off of here. Again, I don't think the scanner thing or the webcam is working. Something happened. Get a lot of issues with these things here. Okay. So the other thing you could do is you could say, well, I have 9 1/2, and I have 3/5. I could, you know, one of the problems is I don't have common units. So if I were to turn these to common units, I would say, what's a common denominator that I could use? Well, you know, to go 2, 4, 6, 8. That's listing the multiples of 2 and the multiples of 5, 5, 10. You'd say, ooh, I have a common multiple. That becomes my least common denominator. So let's make these into tenths. So I'm going to make them both into tenths. 2 times what is 10? 2 times 5, so times 5, so 5 tenths. That becomes 9 5/10. 5 times what is 10? 2, so I'll multiply this by 2. That becomes 6 tenths. So my new problem is 9 5/10 divided by 6 tenths. So you could draw this and do a bunch of stuff as well, but you know what? You could also say, wait a minute, tenths. Here's where you want to be flexible with your numbers. You could say, wow, tenths, I could just think of this. Maybe I prefer to work in decimals. So 9 5/10 looks like this, 9 5/10 divided by 6 tenths. So you could do this. You could do a long division problem, 9 5/10 divided by 6 tenths. Okay? You just have to know that you have to temporarily shift these numbers over. And so there's a variety of ways to think about that, but basically you temporarily just shift this over in order to make this happen. So this decimal moves over one spot, this one moves over. So it actually becomes 95 divided by 6. Okay, so let me just explain that. So if you already know how to shift or what goes on with that, let me just come back here and explain why you do that. So basically what you're doing is it has to do with the ratio. So this is 9 5/10 divided by 6 tenths. So what you're actually doing is you're just multiplying each one of these things times 10. I don't know if you remember that shifting on a place value chart, but when you do that, when you multiply each one of those times 10, it just shifts it over so it becomes 95 divided by 6. And in other words, it's just an easier to work with when you divide. And so that's how it doesn't change the relationship between them. So without doing any more talking on that, basically that's what you have. So let's do 95 divided by 6. So you have 1 time, you have 3 and 5, 6 into 35. There's our 15. And we have 5 left over, 5, 6. So 15 and 5, 6. So in other words, we have enough ice cream to serve 15 people and 5/6 of a guest. But you're not going to have 5/6 of a guest walking through your door because that would be like less than a whole person. So again, we come back to this 15. All right, cool deal, cool. Okay, I think we'll just wind up with this one. And again, you can go forwards and watch different parts of these. You don't have to watch the whole thing. And I know I get a little carried away, but I'm telling you, this math is it's just a lot of fun because there's so many ways to problem solve. And when you exercise your problem solving part of your brain, do not take the attitude that math is just like some kind of a waste of time. It's problem solving. And the last couple things we didn't even use on the division problem. We didn't even use keep, change, flip. We solved them completely differently. Okay, I guess I should go back and I could do that, but maybe I should do that. Hold on here. just so you can see. This one was, let me go back and look. It was 9 1/2 divided by 3/5. So if I were to do that, just real quickly here, I've got 9 1/2 divided by 3/5. If I was going to use that keep, change, flip, I could say, well, I change this to an improper fraction. So that's 19 halves, because that's what's going on here, okay? Divided by 3/5. So you understand that when you're dividing, because of the property of fractions, you're actually saying 19 halves times 5/3. Okay. This becomes 19 times 5 becomes 95. You could decompose this into 10 plus 9. 5 times 10 is 50. 5 times 9 is 45. So 95 divided by 6. And we just did that. Okay, so go back and look. We just did 95 right here divided by 6. And that's how we came up with that. Okay, well, let's take a look at this problem. This problem's different. Uses some pretty interesting. And again, here we have something about trains, and this is scheduling. This is exactly what a lot of companies do. You could be a scheduler. It says at a bus station, buses begin their routes at 6 a.m. Okay, 6. The schedule for 2 of the buses is based on the time intervals listed below. There are a lot of problems like this. They're very common. Bus A has a long route. It leaves the station every 75 minutes. So when we say bus A has a long route, in other words, like say for bus A, here's the bus station. So bus A, let's say it goes out and it has a long route and it takes 75 minutes for bus A. There's bus A. So it takes 75 minutes for it to go out, drop everybody off, and then come all the way back, okay? Let's look at bus B. Bus B has a short route. It leaves the station every 15 minutes. So let's say bus B is just going out and it's delivering people from the bus station. Let's say there's a downtown shopping area right here. So bus B comes out and comes back every 15 minutes because maybe this is we'll pretend there's like a store here, okay? So there's bus B, and that's 15 minutes. So does that make sense? Here's the bus station. We're pretending this is the bus station. I don't know if you've ever been to a bus station before, but basically this is where all the buses come back, and you can go and pick them up, here, and it's going to come back. It's going to pick you up, and it'll take you. This one takes you out to the mall, drops you off, and it comes back, picks up the next load of people. So it's a real quick route because a lot of people want to go to the mall. So every 15 minutes. So if you're driving here and you're like, oh, we got to meet the bus, you're like, oh, no big deal. If we miss it, we only have to wait 15 minutes. Bus A, maybe bus A takes you out. Maybe it goes way out of town to a park. So it's like way out here. And then by the time it gets back, 75 minutes, that's over an hour. So if you miss bus A, you're in like big trouble. So what is the time that bus A and bus B will leave the bus station at the what's the next time? Okay, so what's the next time that they'll leave at the same time? So to do that, the concept you're using here, you're using multiple. So bus B is every 15 minutes. So it's 15 minutes plus 15 minutes. Bus A is 75, 75 plus 75. So the concept is multiples here. That's a big idea that's used a lot with scheduling. So let's just do a timeline. That'd be easier. So now we've drawn a picture of it. Hopefully you got more paper with you because you can do a lot of cool stuff with that. So easiest way is go back to those big ideas. Here's a number line, okay? All right, so let's do bus A, okay? So it's going to be, we're leaving at, it says 6 a.m. So we're leaving at 6 a.m., okay? And there's 15 minutes, okay? Okay, so there's bus A, this is B. This is B. So B is back in 15 minutes, and another 15 minutes is, so actually I'll put 6:15. Okay, and another 15 minutes is 6:30. Agreed? And another 15 minutes is 6:45. This is bus B, bus B. And another 15 minutes is 7 o'clock. Okay, and another 15 minutes is 7:15. Okay, so we'll just draw bus B out here a little bit. Does that make sense? So this is a timeline. So B, every 15 minutes it's back. This is where it's back at the bus station here. Back at the bus station. It goes out, comes back to the bus station. Remember I had the circles drawn earlier? Okay, so let's do bus A. So bus A. Okay, we'll do bus A down here in gray, I guess. Bus A is 75 minutes. So it leaves. So now you got to go out, and it leaves at 6 a.m. Well, 75 minutes. So 6 a.m., 6 o'clock, and then you're going to, and then plus 75 minutes. So you got to think about this. What does that mean? 75 minutes, you can decompose that. That's 60 minutes for an hour and 15 minutes, right? So see what I did? I broke this up. I said, well, 60 of these is 1 hour and 15 minutes. So if we start at 6, 1 hour later, that is 7 is our hour and 15 minutes. So bus A would be like, you know, big long trip, and it's next time it comes back is 7:15. Okay? There's just one way to solve that, and we've got our answer there at 7:15. We could draw that out. Several ways to do that, but I think drawing a picture and drawing that bus station helps a lot too. Always draw, you know, like what's going on here, and then you can decide. A lot of times you use these same tools. Number lines are great. Multiples that we saw. We decomposed on this one. So these same big ideas come over and over again. All right, great job for hanging in there. Thank you for your time. See you next time.